In this video, I'm going to walk you through all the steps associated with testing the null hypothesis of equality of 3 or more means in a design with only one independent variable and a between subjects design. And so at the end of this video, you'll see all the steps to create a report, a manuscript, a thesis, if you're testing a hypothesis relevant to between group means or between subjects means, however you like to say it. So the first step, based on the video that I described all the steps in more detail, is to check the dependent variable is continuous. So I assume you already know what that means, and I'm going to check it, and you can see here that the values are obviously continuous in nature. In fact, they are a score from a 0 to 100. And so I'm very satisfied that these are continuously scored data, and so that means a one-way between subjects ANOVA is a possibility. So I'm going to give a check mark for that one. There we go, we got a check mark for that one. So next I need to check the number of groups, because the number of groups will determine what analysis I can do. And there are 3 groups: argument, repetition, generalization, self-reflection. And these are 3 different strategies to help people summarize information from material. And because there are 3 groups, I can potentially do a protected Fisher's LSD, which is arguably the most powerful approach in this case. So 3 groups, and that's telling me that I could potentially do a Fisher's LSD, which I'd like to do. If there were more than 3 groups, I wouldn't be able to do the protected Fisher's LSD. So next, check normality outliers across groups. I think the most efficient way to do that is to go into Analyze, Descriptive Statistics, Explore, put the inclusion variable in the dependent list, and the grouping variable in the factor list. Click on Statistics, Outliers, that's going to help me, and let's look at plots. I'm going to deselect stem and leaf because I prefer the histogram. Click Continue, and click OK. So this is going to give me all my means, all the standard deviations, the minimum and the maximum. I need these values if I'm going to write a report based on this study, which Friend in 2001 did precisely that. First thing I'll note is the sample sizes are unequal, so that'll alert me to the possibility of problems, especially if I violate the assumption of homogeneity of variance, which I cover in the next step. So I'm just noting that different sample sizes, potential problem. Now I got the core of the descriptive statistics for each group: argument, repetition, generalization, and self-reflection. Each group has the mean, the 95% confidence intervals, the median, the variance, the standard deviation, min and max, and skew and kurtosis. And so right now I'm getting all those important descriptive statistics, and I'm also looking at skew and kurtosis. And you'll recall that absolute values of skew and kurtosis equal to less than 2 and 9 in absolute values is indicative of possibly being able to do a parametric statistic like the one-way ANOVA or corresponding multiple comparisons. And so skewness negative 0.019, kurtosis negative 0.998, well below any value of concern. Skewness 0.515 for the generalization group, negative 0.1 kurtosis, again much less than 2.0 and 9.0 respectively. And finally, self-reflection, skewness 0.21 and kurtosis is negative 1.029, again much less than any value that's a concern. And look at the histograms. The histograms are normalish, and also not really hinting at any outliers either. But to really look at the outliers properly, we look at the box and whisker plot. And you'll recall from previous portions of the textbook and videos that if you get a star next to a case, then that is problematic. But if the most outlying value is only a circle, then it's not problematic. And that's based on the interquartile range rule. And in this case, it's using a multiplier of 1.5 to identify this value. And when it's a star, it's 3.0 as a multiplier for the interquartile range rule. There are no outliers in these data. So the data are normally distributed. There are no outliers, and I can give myself a check mark for that. So now I need to check the homogeneity of variance assumption. So this is an analysis I quote-unquote don't want to be statistically significant, and I'm going to do it as part of the whole package of the analysis in terms of the ANOVA. So I'm going ahead with the protected Fisher's LSD. I've got 3 groups. The data are continuously scored. They're normally distributed, no outliers. I would recommend you use the general linear model univariate approach to doing the ANOVA because you're going to get the effect size estimate this way. Inclusion score goes as the dependent variable, group as the fixed factor. Click on Options, and you want the Descriptive Statistics, Estimates of Effect Size, and Homogeneity Test. Click on Continue. Click on Post Hoc and put your grouping variable here, and we want Fisher's LSD, assuming we satisfy the assumption of homogeneity variance. If we don't, then I'll deal with that. But if we do, I'll carry on. And lastly, I'm going to click on Plots, even though I don't really like the way SPSS does this for a between groups design, but we'll check it out. Click on OK, and here we have the descriptive statistics nicely packaged. We've got the three means, 59.6, 59.8, and then numerically lower at 50.2 for self-reflection group. So it looks like self-reflection isn't a very good summarization strategy in comparison to the other strategies. We have the standard deviations here and the sample sizes here. And we have here the assumption of homogeneity is greater than 0.05, the p-value. Therefore, the variances associated with the groups are probably equal in the sense that there are differences due to sampling fluctuation. This is a good thing in the sense that I can carry on with the protected Fisher's LSD. Check for homogeneity variance, done, it is satisfied. I can check this out without any concerns. Now, the null hypothesis of equality of means, these three means here, this is just the total sample mean, irrelevant for the analysis. Three means here, looking at the group, we've got an F value of 4.078 and a P less than 0.05, P equal 0.019. I've rejected the null hypothesis. These three means are not all equal to each other. Very unlikely to be the case in the population. Here's the effect size. It's actually called eta squared. SPSS is calling it partial eta squared. It's making a mistake in this context. So it's 0.054, which means that 5.4% of the variance in the inclusion score is accounted for by summarization strategy. We have the post hocs. I just want to look at the graph first. We can see that the two means associated with argument repetition and generalization are very similar to each other. And then there's a drop here. This isn't how I'd present the results, but we'll get to that in a minute. Lastly, the null hypothesis has been rejected, but all it's telling me is that at least one comparison is significant. We don't know which one. And we do the multiple comparisons to find out. And we can see that the difference between argument and generalization strategy, which is these differences between these two means here, very tiny, is not statistically significant, 0.950. The p-value is nowhere near 0.05. But argument versus self-reflection, which is this comparison here, argument versus self-reflection, is statistically significant, p less than 0.05. It's actually a p equal 0.011. The last comparison is the comparison between generalization and self-reflection. And that's over here, generalization versus self-reflection, mean difference of 9.60 and a p-value equal to 0.011, which is the same as this p-value here. So these two means are statistically significantly different from this mean, but these two means are not different from each other based on the protected Fisher's LSD. So I've done all the comparisons. I've done the ANOVA, I've done the post hoc test, or the multiple comparisons. I've calculated effect size, but I will note I can't give myself a full check mark yet for effect size because I have looked at the eta squared, but I just want to note that you'll have to calculate Hedges G for each of these three comparisons that you calculated in the multiple comparisons. So you would have to do it for each one, whether it's significant or not. The last thing I'm going to note is you can create an appropriate bar graph this way here. Click on Simple, Summaries of Groups of Cases, click on Other Statistic, put variable in there. We're going to get the mean, group as a category axis. Oops, click on OK. And here is the bar chart that we can potentially include in a report. I just need to change the scale because I want that to be 100. And here we have a chart that is representing the means, and this still needs work to be publication ready, but at least it's the appropriate chart. This is not appropriate because it's suggesting a repeated measure within subject's design, which is not right. So that is the answer to the Friend 2001 study. The two summarization strategies, argument repetition and generalization, do seem to work. So they're better than the control group self-reflection. So that's the end of this video.